Okay, we'll get started. Last time we talked about the abstract class and the polymorphism, and we talked about abstract class, a little bit of the abstract class, and we talk about abstract class. It is a reduced class, so it still is a class. Okay, it still is a class. So today we are going to talk about another reduced class, another simplified class called interface. And then before we talk about interface, we'll talk about the inheritance. You will talk about inheritance. So first thing I would like to talk about is the so-called multiple inheritance. First idea I would like to talk about is the multiple inheritance. Okay, multiple inheritance means that can you inherit or you actually can you extend multiple class? Okay. This one for Jiang, do you know that can you extend multiple parent class?
No, I think.
The answer is not for Java. Yes for C double plus and Python. Okay. So when you learn OOP, you have to know which language you are talking about. For Java, no, you cannot extend multiple parent classes. No. But if you are talking about C language or Python, yes, they are. They have a procedure to look for the parent class constructor to figure out who should be called for the parent class constructor, which one you should call first. But anyway, Java do not allow it. So Java's multiple inheritance you call mixed-in multiple inheritance. Okay. Java's way is called mixed-in multiple inheritance. And then C double plus or Python is called normal multiple inheritance. So in a way, Java is a special, but really, what I should say is that actually, me personally, I believe that this mixed-in multiple inheritance is better. Okay, I personally believe it's actually better. But anyway, this is some concept you need to have before we go ahead for the multiple inheritance. So now, what is mixed-in inheritance and what is multiple inheritance? Okay, so for this one, let's actually look at an example. So right now, if I have a class, let's assume that this class, let's have a class. So this class, let's assume this one is a Honda car. So Honda car may inherit a car, may also inherit another class called vehicle. Okay, there may be another one called Yamaha. Okay, so Yamaha have a boat, so it inherit the boat. And at the same time, you also inherit a vehicle. Okay, so basically, a class can be inherited by multiple class, and a class can inherit multiple class as well. So this kind of environment, we call it multiple inheritance. But in a way, this is not allowed in Java. We just talk about this, what is multiple inheritance. So let's look at inheritance. Inheritance, you actually borrow some feature from your parent class. So whatever feature your parent class has, you will also have. So basically, inheritance is to collect the feature that you have from your parent class. Okay, let's look at an example. So now let's actually look at one example. Hi, Kirsten, how are you?
I'm good. Sorry, I'm late.
So I borrow the same rectangle and oval example from the previous chapter, but anyway, we are not going to use it right now. We will use it later. So first one, let's assume that we have a let's assume that we have so we have several texture patterns. Okay, we have actually different. It's called kawaii drawing. Okay, so kawaii drawing. So kawaii is very, very cute. Okay, so anyway, so here you do have many these so-called drawing patterns. I'm sorry. Many drawing patterns. So some are this is shape, some are this is shape, some are this thermalis. So some with circle, some with striped lines, some with dash line, some with multiple, I don't know what this one is. Actually, it's a fishy fin. Okay, whatever. And some with a heart. So these are different kind of patterns. So if you need to classify them, let's actually look at it. So let's assume that you want to classify them. So first, you may have something called pattern. Okay, so pattern is a class. So pattern is the class. And under pattern, you may have several kawaii patterns. So you may have, let's have pattern with circle. Okay, so you may have a pattern with circle. So pattern with circle, apparently it will extend patterns. Okay, let's assume that it extends patterns. It expands pattern, okay? So the feature that you have from pattern, this circle pattern with pattern would also have it. So let's just put it this way, okay? We just want to show you the example. So now you have a pattern, but you still have another feature that you want to inherit. Let's assume that actually is a circle. But you cannot do you cannot do multiple inheritance. You cannot have this pattern with circle to inherit pattern circle. So this is not allowed. So basically, in that case, one way to do it is that you can create a new class and using interface. And this interface called rounded. Okay, so this rounded is an interface. And then this pattern with a circle, it will extend patterns and increments. Rounded. So in a way, you create multiple inheritance. because your pattern with circle has a feature of a pattern and it also has a feature of rounded. Rounded is a circle, okay? So this is solve the problem for a single inheritance rule for Java, but somehow the interface and the class is different. It's not the same. It's not the same. So what we want to say is, what is the difference right here? So one way you can solve the multiple inheritance way is doing this. You do a pattern and then you do rounding, okay? Another way to solve it is that you do have a pattern. So right here you have some feature that you actually inherited from here and from here. So this one comes with the feature from here and from here. This is multiple inheritance, okay? Another way to solve it, that's actually do it in different way. So another way to solve it, let's assume that we have, let's call it phone. So phone is a class. That's assume is similar to pattern. Okay, I just use a different name. So phone is a class. Okay, anyway, now I would like to have a phone with rectangle. Okay, so phone with rectangle, this is a class that actually inherit from phone. So right here, let's do extends phone. Okay. I do not go into the detail, so I just want to show you the structure of the inheritance. Okay. So this is multiple inheritance, but somehow we also need to have a feature for rectangle to make it multiple inheritance, because your phone with rectangle need to come with the feature that come from rectangle and phone. So one way you can do it is just like this way, you have a multiple inheritance. Another way you can do it is you have labeled the inheritances. So let's actually create another one. This one, let's call it rec. Okay, let's call it recit. So this recit is a square or parallelism, whatever. And then it actually is another class. And then because your rectangle, your phone with rectangle need to inherit the phone. A phone do not have the feature for rectangle, but rectangle you need to have a separate rectangle. If you do multiple inheritance, that's fine. But another way to solve it is that you use this one to extend the rec. Then in a way, you have two levels of inheritance, but somehow it just works like you have multiple inheritance for the phone with rectangle, because you have the feature from here, you also have a feature from here. Even though from here is indirect, but it is still considered to be a multiple inheritance. Is that okay so far?
Yeah.
So these are two ways you can do multiple inheritance. One way is you use a multiple inheritance. The other way is you use a labeled inheritance. A inherited B, B inherited C, so A effectively inherited both B and C. It's just like this, but somehow B had to inherit C as well. Okay. So these are two different ways of doing inheritance for multiple inheritance. Okay, but Java somehow, as I say in the first place, Java class only allow single inheritance. And we invented something called mixed-in inheritance, because you have abstract class and you also have interface. So these are two tools for you to implement multiple inheritance for Java. But if you still not enough, then you may have to consider this multiple level of inheritance. Okay, anyway, so these are just example. I do not design the classes in detail. Okay, just give you the idea of how multiple inheritance can be done. Now let's go back to the topic of interface. So last time we talked about the abstract class is incomplete class. And abstract class, usually they have abstract function, it's incomplete function. So there is a function prototype, but not being implemented yet. Okay, so the subclasses need to implement that function. Then that we call it an abstract class. And object class come with constructor, but the constructor you cannot be used to build a object. The constructor can only be supercoded by the subclasses. So it's only used to initiate the data for the object class, but it is only used to initiate your parent class's data, not really can be used for creating an object. Okay, so that's the idea of object class. Today we are going to talk about interface. So interface in a way is even smaller than object class. So object class only object functions come with abstract function and it is incomplete somehow. Some functions are incomplete, some functions are complete. Interfaces, okay, interfaces, you can only have abstract function and no constructor. This one, even no constructor. No constructor, no variable, no integer A, integer B, no. So it's only abstract functions and the constants is allowed. Final constant is allowed. Only allow two things, abstract function and constants. Okay, so that's the main difference. Abstract class is almost like a regular class, except that the constructor cannot be used to create object. And there are some function maybe is abstract, is incomplete. Interface can only have incomplete functions, abstract function, and can only have constants. Other than that, nothing can be included in interface. So it's a further stripped down interfaces. Okay, so object class is just like template to recreate something. And interface is just some feature, outskirt, just some feature of the outskirt. That's called interface. So here we do have a comparison table for object class and interfaces. Okay, so object class do not support multiple inheritance. And the interface is support. So in a way, you can implement many interfaces. So one object class and multiple interfaces is allowed. So you can implement several interfaces. Okay, that's number one. Second, object class is just like normal class. They have data. Here, interface, no data. Only constant, no data. Object class can have constructor. Interface, no constructor. It has no constructor. And object class contain both incomplete and complete members. And then interface only incomplete methods. Okay, object class can contain access modifiers, so public, private, those kind of things. And then interface, everything is public. Everything is public. You do not allow any private data views or private function. Okay, interface cannot be static. An abstract class can have static members. Is that okay so far?
Yep.
So this chart, I think, is very important. This chart, I think, is very important. Now comes the question. So why do we need interface then? Since you take down everything, why do we need an interface? Okay, that's the question. Why do we need interface? So interface is created because you need to have multiple way, okay, to do it, to do something. Okay, let's do this. So let's assume that we have a class. Let's call this class called chicken. So we have a chicken. Let's create another class. Let's call it fish. Let's create another class called tiger. Okay, let's create another one that's called carrot. Okay, so we do have 4 different classes. Now we want to group them together in a way, okay? We want to group them in a way. So let's actually create a object class. So this object class that's created as memo. So memo, only tiger is memo. Okay, so tiger is memo. Tiger is memo. Now, let's actually create another one. Let's create another class. Let's call it animal. So animal including fish, chicken, and mammal. So mammal is an object class, but it still can extend animal. As long as it's under animal, that actually should be fine. So it's okay. So fish is also animal. Okay, now chicken is also animal. So chicken also extends animal. So right here, we do have one object class, memo. Memo, there's no such animal called memo. Actually, it's actually a collection name. Okay, but it's okay, it's an object class. So above object class, if you put a concrete class animal, is that okay? That actually is okay. So you can put a concrete class on top of it, object class, and then another concrete class, and then another object class. That actually is fine. This is actually fine. Okay, if you do such inheritance, that actually is fine. There's no requirement that your object class can only inherit a object class. No such thing. Okay, no such thing. Okay, anyway, these are the object class. Now, interface. So you may want to create an interface called edible. Edible means that can be eaten. Okay, so this edible right here, I'm going to create a function. This function called can eat. So when you write this one called public void can eat, this one is a function, that actually is an abstract function. So if you write this way, Java compiler will automatically fill out for you. You automatically fill out abstract for you. So you write this abstract or not writing this abstract, you will end up the same. So that's deleted. That's deleted. You will just Java will automatically add abstract. Is that okay?
Yeah.
Yeah.
So in a way, this edible. So edible is something can be eaten. So carrot can be eaten. So we say this one increment edible. Okay. Now, because can eat is a function that is object function. So now because your carrot implement edible. So you must implement the function public void can eat. You must implement it. If you don't implement it, then you will have you are not correct. Okay, so you might implement function. So when you say implement edible, then the can eat function is a requirement for you. You must implement it, okay? Let's see, something wrong. Edible interface. No, this one is wrong. I create some wrong thing. Let me delete it. Okay, let me delete it. Let me create one more time. This is new, and I need to create interface. Okay. So it should be an interface. It should be public interface edible. And right here, I want to create public, okay, void can eat. Can eat is an abstract class, abstract function, so there's no need to use curly brace, just use a semicolon. That should be fine. And then your carrot is implement this interface. So there is a function for it. Now your chicken can also be eaten. So it extends animal and it also implements edible. So since you implement edible, so the same thing, you need to have the public void can eat. Okay. So in a way, chicken inherit the animal class in implement edible interface. Now fish is also edible, so fish. So fish also implement. Okay, fish also implement edible. So because it implement edible, you also need to put in the any function. Okay, so this one print out is anyway. So we do have three things, three classes implement edible, two classes extend animal, one class extends mammal. Okay, so this is how the inheritance is. Let's create a tester class. So let's test edible. Okay, so let's create a carrot. Let's create a chicken. Let's create another one called fish. Okay, and then because the edible is an interface. Okay, so edible is also a stripped down class. So you can do edible array e list equals putting in your carrot, chicken, object, and fish together. And you do for edible okay, so each one of them has the capability of can eat. So can eat itself is a capability. So in a way, this edible can also be used to group the chicken, fish, and carrot together. So this is also another kind of inclusion polymorphism. Is that okay so far?
Yeah.
In a way, interface is a stripped down class, so it still be a class. It's a tiny class, no data, no constructor. You cannot use it for building object, no. But it still has the capability of being able to become a data type, and you can group multiple things that implement the same thing into there to put them together. So it's a stripped down class, but it still has the inclusion polymorphism. Okay, that's called interface. Is that okay so far?
Yeah.
Easton, are you okay so far?
Yeah.
Okay, so now we are going to talk about the most common interface that we see. Usually we do see the comparable interface. Okay, this probably is the only one that AP would test. So comparable interface. Remember that we have a point, you need to implement the compare to function. Okay. Okay, let's actually do this. Let's create a class, let's call it SAT. So this is SAT score. And this SAT score, we will do implements. Implement what? Comparable of the SAT. Okay, so this is a interface. It implement comparable SAT. You can do comparable object, but then your compare to need to use for the object type. But here we want to compare SAT. So you need to have public integer compare to compare. Anyway, this SAT, you will have a integer score. Okay, and your SAT, you have integer S, and then your score equals S. So right here, you have public compare to, and this compare to, you want to compare to SAT other. So if this that score greater than other that score, you return 1. If this that score less than other that score, you return -1. Otherwise, return 0. This actually is a comparable interface, the use of a comparable interface. I think this one is a minimum example already. Okay, smallest possible interface. So this one you will also have a string function. Okay, you just print out your score anyway. So this one is your SAT now. Let's actually create something called test SAT. Okay, so this SAT class implement the comparable. So you can do arrays, the sort, and you sort on S list. And then you do system.out of green line, your arrays that string on your S list. So you'll be sorted according to the sorting algorithm. But the key point is that you need to implement this one, the SAT class, need to implement this compare to function. So compare to function make the SAT can be compared. So we call it comparable. So usually interface is a function, is an abstract function, and you implement that you got some ability, you got some capability. So in this case, comparable, you implement comparable, you make the SAT class can be sorted, can be compared, can be sorted. Okay, so here show you it is sorted. So if your SAT does not implement comparable, then arrays.sort will not be able to be used. So usually interface give you some capability. So in a way, a chicken class is edible. A chicken class can be frying. No, chicken cannot fry, but chicken can be running. Okay, tiger can run. So there's a runnable interface. So chicken and tiger with the run capability. Okay, carrot and fish, no running capability. Swimming, fish can swim, the other cannot swim. So those are different capability. You can have different interface for them to implement. Is that okay so far?
Yeah.
Jiang, is that okay so far?
Yeah.
Okay, so that's what we talk about for the interface so far. There are several interfaces that we would like to discuss. So abstract class is a class that with some incomplete function, okay, but you use this one to as a template. It still be a class, okay. Okay, let's go through faster now. So number class is a abstract class. Okay, we talked about it before. Usually number class is only for grouping. And then we talk about interface. Interface is features. Give you some features. Anonymous class. Anonymous class, actually this one we actually show you in the array already, okay? It's a object without class name, okay? Okay, interface, we talk about interface. Interface is some capability. We cover this uncomparable interface. So now let's look at other interfaces, commonly see interfaces. Another one is called clonable interface. Okay. So clonable interface. So clonable interface has only one function called clone function. Okay, this one function called clone function you need to implement. So clonable means your data can be cloned, In a way, so-called can be copied. Okay, let's look at this one. So let's assume that let's go to Tiger class. Okay. So this is Tiger class. Let's assume that you do have a, let's see. Okay, let's actually have a string called location. Okay, so Tiger, and then you actually put in a string as, and your location equals as, okay, whatever. This is your constructor. Now, if you want to clone this Tiger, so let's assume that you implement clonable. Then you need to implement a function called clone. So you need to know about a clonable, and you need to capital. Okay. And clonable, you need to clone, and then you want to, let's see. I'm sorry. Clonable. Mission the E. Clonable. Okay. So you need to implement a function called clone, so that the public Tiger clone. Okay, and then you create a Tiger other equals new Tigers, and then you put the location into there. Return the other. So this one is your Tiger have a variable called location. So you create a new Tiger object. You copy your location from here to here. And then you return this new object. So it's a two different objects, but same location. Is that okay so far? And
Yeah.
this is creating the clone copy. Okay, it's creating a copy. So this clone function, I think is lowercase, not uppercase. Okay, and then you can use it to clone. You can use it for copy and cloning. Okay, so let's do it. So here we give you the idea of what is interface, and hopefully you understand what is interface, and you need to use the knowledge to study the Java's data structure. Okay, you need to use that to study Java's data structure. Okay, something like that. I just want to give you the idea of what is clonable function. Any questions so far?
Nope.
Next one, okay, this one is not important. Clonable is not that important, okay. A more important interface is the next one that's called, okay, clonable is a shadow copy and big copy issue, okay. Whether you want to go down to clone several level or not, okay, that is you need to remember the clone. Now, next one is more important one is the iterable and iterator interface. This one happened in the data collection more, and I think it's the most important interface that you need to learn. It's called iterable. There are two interfaces. One is called iterable. The other one is called iterator. Iterable is iterate. Iterate means you can count it. Can be count one by one, one by one, one by one. It's iterable. Iterator is the counter. So you need to implement both the iterator and iterable into an interface so you will be able to use it. So here you have iterable, you implement iterator, then you need to implement the iterator. And then your collections, your list set, queue map, everything implement iterable. So it also has the iterable and iterator. Most of them, everybody that you know for data collection can be iterable. Okay, so what is the main purpose of iterable? So Tiang, what's the advantage of being iterable?
You can loop through it then using like for loops and for each. I think you can use advanced for loops if it implements the
You can use for loop.
advanced for loops.
So you do for integer I equals 0. This one you don't need to be iterable.
No, I mean advanced for loops.
If you do for each integer e from A array, I'm sorry, okay? Then this one need a iterable, okay? These things need to be iterable. Is that okay? So one
Yeah.
thing that we know is iterable is array list is iterable, linked list is iterable, set is iterable. This everything here is iterable. Okay. So iterable main feature is that you can put into this for each loop. Okay, you can put into each for each loop. Then you need to have an iterator. It's iterable, and iterable also implement iterator, so you need to have an iterator. Okay, so iterator is a counter. Iterator is a counter. Iterable is a feature. Okay, so when you implement iterable, there are three functions associated with it. So Kingston, do you know what are the three functions associated with it?
No.
No? How about Jiang, do you know?
Wait, what?
What are the three functions associated with the iterable? When you
I don't
say someone is iterable, there are three functions associated with
maybe
iterable.
like operator brackets.
Hmm?
Operator brackets maybe.
No. The three function is has next, and remove. These three function is a default function that iterable need to implement, just like compare to or comparable. If you implement iterable, then these three function must be there. Just like comparable, you must have it. Is okay? These three function has next, and remove. This three function is a must. So from here, you know who is a iterable. Something you already know is iterable. Which class is iterable already? Scanner is iterable. Is that okay? Scanner has these three functions. Does that make sense?
Yeah.
So right here, you give you an example. You have an array list. You add 1, 2, 3, and you create an iterator, and then you have as a next, the next. Okay, let's try this one. I'm sorry, a little bit off. Iterable must has an iterator, and iterator has these three functions. It's iterator that has these three functions, okay? Not iterable. Okay, anyway, let's try out array list. So array list implement iterable and iterator, okay? This one cannot be imported. I'm sorry. This one cannot be imported. Okay, let's go. Okay, so we add 4 number into the A list. Now, usually you do for loop for each loop, but you can also do this. You can also do, let's see, actually, let's do iterator. You create iterator of integer type associated with the A list. And you do while idea that has next. And you do system that out the free line of ITR that next. This is how you use the iterator to go through each individual one in the array list. We did not teach you this in the array list because more advanced topic, but we would like to cover it here. Does that make sense so far?
Yeah.
Jiang, is that okay so far?
Wait, can I see the
Mhm.
sorry, can I see the code again?
The structure is very similar to the scanner,
Oh, okay. All right. Thank you.
okay? You just have the array list that you do streaming one by one. It's called iterable. Iterable is you can count one after another one. So you need to have the next function, go to the next one, go to the next one, go to that's called iteration. Okay? And you also need to have has next function. If you run out of has next function, you don't have next data. So these 3 features are the basic features that you need to have: has next, next, and remove. Right here, we do not use remove. But array list of integer do have the iterator and it has next implemented. Okay, that's something you need to know. So this iterator is very important. If you design a new class, say dynamic array, and you want to make it be iterable, and you want to use it for each loop, or you want to use this kind of iterator to point it, you got to implement iterable and iterator interfaces. Okay. If not, then you cannot use these. Okay, anyway, this is the iterable. So if we need to build a new class with iterable and iterator, usually we use a dynamic array as an example. But right here, we do not want to go to there. It will burn a lot of time for us. We'll do something else for interface, okay? We'll do another example. Okay, anyway, that's actually the interface, another important interface called iterable and iterator. And if you study the collection, data collection, you will need them. Otherwise, you don't know what they are. Okay, for each loop is available after JDK 8. So version 5 it become available. Okay, starting version 5. Right now it's version 26 already. So long time ago. But remember, when you test, it's testing on only Java 8, okay? For AP exam, it's only Java 8. So there is an iterator, there's another one called this iterator. This iterator only has next, and remove. And this iterator has a previous index, has next, previous, next. So it has this iterator is dual direction, bidirectional. Okay, bidirectional. You can have the previous and next 2 functions. Okay, this iterator. In a way, your already is implement this iterator, not just iterator. It's implement this one. But this iterator extend iterator, so it will also have the iterators feature. Okay, there's a whole iterator package you can do. But now let's look at something else. Okay, let's don't look into these garbages. Let's look at the real world problem. Now let's go back to our example. Right here, we do have a rectangle shape, oval, everything. Okay, so you do have a shape. So on top of the shape, we are going to create another one. This one, I'm going to create an interface. And this interface is called drawable. Okay, drawable. So this drawable will implement one function. It's a very simple one function. It's called public void draw. And this draw function, because you are going to draw it in the graphic mode. So we are going to include graphics G. So we will import the java.awt.graphics. So one function, you pick your circle or your rectangle or your prism drawable. Okay. So we create an interface called drawable, and then our shape, every shape will implement drawable. Shape implement drawable means that everybody now has an incomplete function. These, everybody has incomplete function. You must make it drawable. So now let's look at this rectangle. So since rectangle implement rectangle, so here let's put it here. Okay, so graphics. So now because you your parent class implement the drawable, so you must have the draw function. So public draw. Okay, and then that's actually this one that's also import. Okay, also import color. Okay, this will create a number between 0 and 255. Okay, so that's red color. And that's actually copy, paste. So that says the red, green, and blue three color. And we'll create color C equals new color. Okay. Now we also need to have we do have the width and height right here. Okay, we have the color, so your graphic need to set color. So let's see, Java graphics. Set color, so you will use set color is set color there. Okay, G that's set color. Okay, so let's do G that's set color of the C. Okay, and then let's do okay, so this is I fix the location in 100, 100. Okay, so these two, the X and Y, you can make it a variable for rectangle, but I don't want to do that. Okay, you can make it as a variable, but right here I just fix it. It's a fixed location to draw a rectangle. Okay. No, let's do this. Let's do it in a different way. Let's do. How about this? Let's call up. This is called left and top. Okay, let's do this. Let's do the left equals master random and 300 plus 100. Okay. So this is from 100 to 400 possibly. Now let me change it to 0. So it would be 0 to 300. So this one is copy it and then put another random one for the top. Okay. Now, this one is the drawable function for rectangle. So prism and square, if you want to modify it, you can redesign the draw function. Overall, so far we do not have a function. I'll do it later. But at this moment, let's create a test drawable. Okay, let's create test drawable. So test drawable is a drawing function. Okay, so here. Let's clean up. Okay, I'm going to open the library. I'm just to copy. Okay, I don't have time to redo it. So let's copy from somewhere else. Okay, let's do this. Let me just copy from chapter 10. Don't copy somewhere too far. Copy from chapter 1. Your chapter 1 we do some graphics, so let's easy directly copy from there. Okay. Let's see, let's do test window 3. Okay, let's try to use this one. Copy the whole thing over. Oh, this one too much. It has no, we don't need that. Let's use an easier one. Okay, let's do this one. Grab JFrame. Canvas. No, let's try another one. No, none of them. Okay, let's use a test tree. Okay, let's copy this one. Okay, this one, let's copy it right here. Okay, the inclusion, I think is fine. Let's put on top. And then thread, we don't need that. We don't need to use the loop. We don't need loop. Let's delete it. Dimension, everything right here, okay. So this one is 10 JPanel. Okay, let's extend JPanel. Okay, so JPanel is a class. Okay. And this one, we do not have the animation, so delete the animation part. So this one, JFrame, let's do my shapes. Okay, my shapes. And then this one should be, let's change test drawable. Okay, it's called test drawable. So test drawable. There's no parameter, let's delete the parameter. Okay, size 800, 600, okay, background color, BG, okay. Background BG right now is gray color, that's fine, okay. And then XY, we do not have XY, delete the XY, we do not need that. We do not need that. We do not need that. This one is test drawable. Test drawable, what's wrong with it? Oh, this missing a. It's drawable, okay. Dimension 800, 600, exit, okay, everything okay. Clear screen, okay. Draw companion, this one, let's delete the join right here. We actually, when you paint, you clear the screen, then you delete this. Okay, now. So far this one is just has the background color, nothing else. Okay, let's run it. Just make sure it works before we put in the more complicated data. Okay, so the background gray color show up, it's okay. Any questions so far? Now we want to create multiple element that we want to put into there. So we want to create a rectangle. Okay, let's create rectangle, square, and prism. So here, let's do here, because you want to have a data that's shared by your paint component and also your constructor. So right here, you will create shapes. Okay, so I create a S list that is three shape. This three shape right now only have rectangle, square, and prism because other oval type or circle we do not have the join function yet. So every time you draw it, you will clear the screen and then you will do for what? For each shape S from your S list. And you do S dot draw. Because your S is drawable, it has the feature of being able to be drawn. Something, oh, here is S, not D, S. S dot draw. Oh, you need to pass the graphic into there, so let's pass G there. Okay, no problem, let's do it. Is that okay so far?
Yeah.
Prism, we do not print 3D, and squares, it's okay. Square just print like a rectangle. So right here, if you do want to improve it, you want to improve the drawing function for prism or square, that's up to you, okay? Right now, I just implement one function in the rectangle, so it can be drawn. Is that okay so far?
Yeah.
Now let's do this. Let's actually copy these things. Put it into the oval. Okay, let's make the oval class also drawable. Right now, also, I don't implement the draw function in the circle and the sphere because it takes much more effort. But right now, we just do drawing for the oval. So provide a parent function so that everybody got service, even though that's not a good service, it still has some service. So the color being set, that's fine. And then right here, this 11, right? Let's do 400. So put it in different location, okay? And then here, oval. Okay, width and height, top left. This one, let's try 300. Let's try 400. Okay. So that's done. Oh, here it doesn't have the width and height. So let's use 2 times A and 2 times B. Okay, it's oval, it's different. Okay, anyway. Done. Okay, no problem. Let's go back to the test drawable. For test drawable right now, I have a rectangle, square, prism. Let's continue. So let's do new oval, 50, 40, 50, new circle, 80, new sphere, 44, whatever. Save. And let's run and draw it. Is that okay so far? I think the number is too big. Okay. So far, okay.
Yeah.
So what I want to say is that this one give you the idea of what is the interface. Interface give you some capability. So right here is drawable. Drawable means you can be drawn. You can be drawn, so rectangle can be drawn, oval can be drawn. Even though square and prism, circle, and the sphere, we do not have a detailed drawing, but their parent class do take over the basic drawing for you. You still can draw them, even though you it's not accurate or pretty. but you still can draw it. So right now we show you the idea of how to implement the interface to make every object drawable. So far we cover the class, parent class, child class, abstract class, interfaces, and also the group operations. Okay, multiple inheritance. We already completed the whole thing for OOP. Is that okay? You are ready to study the object-oriented programming in the data structure and going into the competitive programming. And this knowledge is also applicable to Python and C++ with some modification. I mean, just tiny differences, but Java gives you the best idea of what object-oriented programming is. The purpose is to manage the objects. Okay, so why we use BlueJ? As you can see, BlueJ gives you the idea of how your class is being organized. Okay, so for high school student, I think it's a very good tool. Okay, it's a very good tool. Help you to understand what they are, what is multiple inheritance, what is relationship between classes, what is tester classes, what is data classes, what is interface. Okay, they have everything that you need in the BlueJ environment. Okay, it's a simple and easy to use. Any questions so far?
No.
No, no question? No question. Let's do another things. We are 9:22. Okay. So we do show you the drawable. Let's do another thing. Okay, let's do another thing. Now let's quit the project. Let's go back to the previous one. We still have some time, so I'm going to cover the tic-tac-toe game. I'm trying because we already teach you the interface. So what I want to do today is that I try to cover the XMOR operation today. And then if we have time next time, or maybe we have time today, I may cover the graphic mode so that you can write a game in tic-tac-toe game, okay? Is that okay?
Yeah.
So this one, let me call it tic-tac-toe 2, okay? I'm copying from chapter 3's tic-tac-toe. So I'm going to continue from here. So last time we do cover, let me see, interface. I'm going to go to the tic-tac-toe 2. Last time we do cover chess and board and tic-tac-toe board. So we do have the inheritance structure, but now we want to put a controller in, okay, and the game playing in. So last time we do work on this board, tic-tac-toe board, chess, okay, and I have you to do the homework. Now I'm going to cover this tic-tac-toe game. So let's try to run this test board one times. So this test board is a tester. Okay, so you would draw the board and then put some stone and draw the board again. Okay. That is what it is right here. Okay, so we are going to do another one that's called tic-tac-toe game. Okay, let's do tic-tac-toe game. So this tic-tac-toe game, we will write a game for this one. So we will do import java.util a scanner. We need a scanner. we'll do oriented way. So we do again. Okay, so if you have a tic-tac-toe game, and then this one you should, because you are going to play a tic-tac-toe game, so you need to have a tic-tac-toe game board. Right, so tic-tac-toe game board, you do have this tic-tac-toe extend board. Okay, extend board. So let's do here. Let's have a tic-tac-toe. Be a sport, okay? So be a sport. So when you construct it, you actually do constructor, you do B that, I'm sorry, you actually do B equals new tic-tac-toe, okay? So you create a tic-tac-toe board, and you also need to have a character turn. Okay, default turn, let's actually set it to be X. Okay, so you actually set it to be X. You want to use local X is fine, but here I use a tic-tac-toe class. You would want to put a final string that actually is fine. Okay, so initially you have a turn that is set to the tic-tac-toe again. Okay, then you need to have a Boolean variable for game over. So you're not game over yet. Okay. So when you start a game, you actually create a board and then you return set to the X. This one can be determined by computer random number, okay, but it's okay. Right now, let's pick X as the turn. Okay, so let's do this. Now let's have a public void run, okay, run function. So this run function here, okay, so while not game over into the following scene, okay, into the following scene. What you would do is actually you do have a board, so you do B dot, let's see, your board, you want to show it. So you would do board dot show first. After you do board dot show, you want to get some input. Okay, so you would do scanner. I'm sorry, this scanner need to be before it. You said that the scanner should be set up earlier. Okay, so right here, what you would do is that system.out print. Okay, and then it's so you print whose turn first, okay? And then you do system.out print line, okay. Okay, you got use the next line to read in actually here read in your MOOC, okay? So if you that MOOC the length greater than 2, not equal to, you try to enter your MOOC. So we allow A1, A2, A3. B1, B2, B3, C1, C2, C3. If the length is not equals to 2, okay, so right here you want to show, but before you do show, you will do system.out.print. That's actually print /F to clean up the page. This one, clean the page. Okay, clean the page. So you clean the page and then you show the ball, enter the move. If the move is not 2, you will do continue. Okay, you will do continue. So right now let's just set up a counter. So that's integer count equals 0. Okay. So right here, let's do if count equals 9. Then over 2. Okay. So here, every time you count, it will increase. Now counting number of steps. Okay, if the length is not equal to, you will continue. You continue, then the counter will not advance. You will go to the next iteration. Okay, this is bypass. So basically, if you are length of 2, it's a legal move. We will check it later. And then you start to increase your counter and then make sure that your counter don't go over 9. Okay, so this one is the wrong. Now you have the wrong function that's actually have a main function. So let's do base scaling for email. So let's create a T F O N TT equals T F N and TT the wrong. Okay, then you can test this wrong function. Let's try. Okay, so here you start with this and then you say extern. So now let's do A2. Okay, it take no action because we do not do anything. Okay, but at least this one so far. Okay, so let's try 1, A2, 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 A2. 9 of them, then you get out. Okay, so basically the counting to 9 work. Now let's continue. So this one for the input. Okay, now this one, let's try. First thing is we want to check the length is 2. Okay, so let's see. So character R equals okay, we only take A, B, C. So if you are less than A or greater than C, the character, then we will continue. It's illegal move. Or if C actually less than 1 or C greater than 3, then we will continue. Is that okay so far?
Yeah.
Now next one we'll do integer row equals integer your R minus A. So this one, when you have A will go to 0, B will go to 1, C will go to 2 for the row. I'm sorry. I make a mistake. So this one is called C, this one called R. It's the opposite, okay? Okay, so this one is called it polar. Okay, so this one give you 1 will go to 0, 2 will go to 1, 3 will go to 2. Okay, so you have your row and column. Now you can use the row and column on your board to check whether they are a stone or not. Okay, so if the board that get for function has a get function to get the location of the row and column, they will return a character. So if you get the row and the column now equals if O S, if not a space, you continue because illegal move. They already has a stone, so this one is not allowed. Okay, you will actually recheck it. Otherwise, B dot set column. I'm sorry, row and column. And then right now you will go for 9 of them and here it finishes. So here you check if it's an empty stone or not. If not an empty stone, you will put a stone into that location. Okay. And then continue until 9 of them. You do have a game over. Okay, we'll check the B dot set. I'm sorry. There's a set function, right? Oh, there's a mark. There's still another variable called mark. So you put the turn into there. Now after that, you also need to you put it into there. You need to change turn. Okay, so change turn. So your turn will be equals turn equal to oh that is. Then you will return it oh that O S will get X will get the O and O will get the X. Okay, change turn. So this one change turn. Okay, anyway. Okay, so you get out, okay, you get out now. No, that's actually after that's actually continue. So this different turn, every part is actually okay right now, okay, now. So right here, you check the game over equals to, if count equals 9, you will have a game over, okay. So right here, we would say, so winner initially we set it to be the, okay, let's use, put it into the constructor. Okay, winner initially set to the S, okay. So if it's win of the game ball B, and then, okay, I'm sorry. This one should be B that is win of the turn. Then the winner will be equal to 10. And then game over will be true. Okay, then game over will be true. So here we will check if there is a win for the tic-tac-toe game or not. If there is a win for the tic-tac-toe after setting the stone, if there is a win for it, then we'll declare the winner, and then game over will be true. Okay, game over will be true. Okay, now that's good enough. Okay, that's good enough. Now let's go back to the ball function, tic-tac-toe function. Because this winner rule is not on the ball, it actually is on the tic-tac-toe. Okay, so right here, let's do Boolean is win. Okay, is win, and then character mark. Okay, we'll check if the mark is win or not. So right here, you actually have the array M. Okay, you have the array M. So now you would like to do, if there is a horizontal wing and vertical wing, and you may have a diagonal wing, you may have reverse diagonal wing, okay? So now you start to have a check-in for the diagonal. Let's use this diagonal wing, okay? So here let's have a Boolean variable win equals false. Okay. And then let's set the diagonal win. So win equals 2. And then for integer I equals 0, I less than enter length, I increase. So diagonal turn, you check if ends I not equals the mark, then win will equals false. Okay, win will equals false. So if win, you will return true. Okay, that's actually diagonal win. Let's write the reverse diagonal win. So you set the win to be true as well. Then you do for integer I equal 0, I less than n, the length I increase. Okay. So right here, if n I and the length minus 1 minus I, the symmetrical location now equals mark. Win will be equals force. So if win return true, otherwise return false. Totally no win, return false. So we finished the diagonal win and the reverse diagonal win. Okay. Diagonal win is to check if there is a win, I will the diagonal items. Reverse diagonal wins is checking this one, this one, this one. So far, okay? So far, okay?
Yeah.
Now, next one, we are going to go for the horizontal win. Okay, so horizontal win, you need to check 3 rows. So for integer r equal 0, r less than, and the length and r increase, okay? Each one of them, you set your win to be true first. Okay, and then you do for integer c equal 0, c less than r, and r, the length, c increase, okay, e. Okay. This is mark. This is not it's mark. So this is to check the horizontal win. Next one, we are going to check the vertical win. So vertical win is to check every column if they are the same mark or not. So here we use the M0, okay? That's it. Still one error. Typo. So we got a is win function, okay? No, that's wrong. Okay, so A3 already had the win, but we haven't decided the winner. Okay, but it already detected that S3 is a win. So let's go back to finalize the program, okay? So now you actually get the win, it's go over, you get out. So after you get out, the first thing you would do is you would actually refresh and throw the ball one more time. Okay, refresh and throw the ball one more time. Refresh and throw the ball one more time, and you say if winner equals but S, then you do the following thing. You say system that out the point line then hide else system that out the point at then 1 by percentage C percentage N winner. That's it. This one determine who is the winner. Okay, let's do it. Okay, is that okay so far?
Yeah.
So this one show you how to design a graphic mode of a game. It's not too hard. You actually have input, you validate your input. If not, you actually redo input. And then after you get it, the input, convert the coordination to the column and row. And then you set a stone to the column and row and you check if it's a win and game over condition. And then you change turn or you advance the counter. So if your counter advances to 9, that means that every cell being filled, there's no winner. The game over still to be true, but the winner is the S. The game is tied. Otherwise, there will be a game. There will be a winner because the winner is declared by the is win checking. Then you will actually print out who won the game. Okay, so this one is a text mode game. So we do show you how to do OOP with this. Next time, if we have time, we will do a tic-tac-toe game with joy. So we'll give you a tic-tac-toe game board. Now entering ABC, we'll click to play tic-tac-toe game. Okay? Is that okay so far?
Yep.
So in a way, I'm showing you how to build a bigger software. Right now, it's tic-tac-toe game. It's a bigger software, and also I'm showing you what is interface, what is join function, what is the collection function that you can use. Okay, we are building up your knowledge in software libraries. Okay. Okay, if no question, that's it for today, and see you next week. Okay, next week the coding practice will resume. Okay, good night and bye bye.
Thank you. Bye bye.
Thank
Bye
you.
bye.